This is what we call a single displacement reaction. And right here we have an example of this. And here is the lead nitrate. And pour a little bit into the test tube very carefully.
See, it works pretty good on here.
Yeah.
And then we will take
So sometimes it's just
a piece of zinc.
That books guys are cheap. They're not bad.
And
Cheap.
here we go.
So they only have so much. They're not bad.
The reaction will occur, but you won't be able to see it right away. So we'll put this in and come back and look at that later.
Okay, now we have a double displacement reaction, and a double displacement reaction is where the cation of one aqueous solution, both of these solutions are aqueous, switches with an anion of another to produce a precipitate. Right, so we have barium chloride right here. We're going to pour that into a test tube. Okay, there we are.
If you look up in your book, even your textbook,
Now we have
that is.
silver nitrate. If you want to see that right there. Yeah. There it is. And we're going to slowly pour that into the same test tube.
Violent reaction is using, and then as soon as we find out. There you go. We're aware of that.
And instantly we get a white cloudy foam formed into the barium chloride, which means a reaction has taken place. And that, folks, is double displacement reaction.
Alright, here are the results of the single displacement reaction. Zinc reacted with lead nitrate because zinc is higher, more active than lead to form zinc nitrate and lead. Lead is a solid, zinc nitrate is an aqueous solution. As you can see here, lead formed around the piece of zinc and became a solid. Alright, now for a double displacement reaction. Alright, barium chloride reacted with silver nitrate. They're both aqueous solutions to form barium nitrate and silver chloride. Silver chloride is a solid, so you can tell there's a reaction, and as you can see here, they formed a little bit of precipitate on the top.
Here we have ionic and non-ionic equations. This is lithium barium chloride yields barium plus lithium chloride, and you have to balance it. And so you put a 2 there to balance the lithiums, and then a 2 there for the 2 lithiums, and then 2 chlorides, and there's 1 barium. And then here you have to break it up. So there's 2 lithiums solid plus, and a solid you don't put a charge there, and then plus barium, and the charge is plus 2 aqueous plus 2 chlorine aqueous, and the charge is minus, yields barium solid, no charge, plus 2 lithium plus aqueous plus 2 chlorine minus aqueous. And then you have to circle the spectator ions, and the spectator ions are the one that are exactly the same. And so the 2 lithiums aren't, because this is solid and that's aqueous. This has no charge. The 2 bariums aren't, because that's a solid that's aqueous, and so it's the 2 chlorines. So you circle those. And then you rewrite it without those. So it would be 2LiS plus Ba plus 2 aqueous yields BaS plus 2Li plus aqueous. And you gotta make sure that the charges are balanced. And so there's 2 positive charges on this side, and there's 1 positive charge of lithium, but since there's 2 of them, that means there's 2 positive, so they're balanced.
Glucose! Some background information that is necessary to know about our combustion reaction with glucose is a plant, like a potato for example, is primarily a chemical storage system containing glucose molecules manufactured during photosynthesis. there are two types of carbohydrates, simple sugars and also complex carbohydrates. Simple sugars taste sweet and are broken down fairly quickly, and on the other hand, complex carbohydrates are long strands of simple sugar units bonded together. Also, the type of chemical reaction that is occurring while I'm chewing these wheat thins in my mouth is a combustion reaction. The glucose in each and every one of these wheat thin crackers is reacting with the oxygen in my mouth while I'm chewing, and that yields CO2, H2O, and then the energy that goes to my body. The actual balanced chemical equation of this is C6H12O6 plus 6O2 yields 6 CO2 plus 6 H2O plus the energy that is given to my body. This chemical reaction relates to our group theme because it is, first of all, a combustion reaction is found in chemistry, and the carbs are broken down into water and CO2 and also energy, which are all taking place in my body. And this reaction in general is very important to the human body because without this glucose reaction, our body would have no energy and our body would not be able to function.
Hello and welcome to Iron Chemists of America. Today we are showing you how chemistry is used in cooking. Now I've got some sodium bicarbonate here, and I'm showing you how it is used in making these pancakes. Now, sodium bicarbonate is broken down in a decomposition reaction with heat to make sodium carbonate, CO2, and water. Now as you can see here, the CO2 gas is bubbling here and making the pancakes rise and make them bigger. And now we flip it over, we got our pancake. Now that's a thermal decomposition reaction using sodium bicarbonate. This is how chemistry is used in cooking.
Hello! Today we'll be learning about food chemistry, and it's lots of fun. Whether it's from eating some chips or chowing down on some apples. The enzyme called amylase in your mouth is what breaks down your food. We'll take a closer look at this in the lab. Okay, here we are in the lab, and I have set up a little experiment for us to test and observe what happens, just like when you're chewing food with food chemistry. Here I have some potassium chloride, which is similar to the chemical formula for amylase, the enzyme that's found in your mouth when you chew. So here we are, we're going to go over and we're going to see what happens.
Oh, we're telling me the wrong thing to do. Say that.
So first we're going to carefully light our Bunsen
You
burner,
make me a sad little boy.
of course with my goggles on. Alrighty, now we gotta melt this, and by doing this, the potassium chloride decomposes, and this is an example of kind of when you're chewing, when it reacts with the oxygen. And food calories, or the calories in the food that you eat, we'll drop a Cheeto in and it'll show kind of the reaction that you get when you eat. Just gotta wait for that to melt and decompose down. Alright, now we're gonna put a Cheeto in very carefully. Alright, and we'll see what happens.
There we go.
Woo!
Yeah.
Alright, and that is the kind of reaction that you get with food chemistry.